Login accepted.
Hello, everybody. How are you today? I hope you are fine. That's the last day of the conference. Usually we have a closing keynote, but this year we are trying something different, so we moved the closing keynote to the morning. Not sure if it was a better choice or not, but after the lunch, many people are heading home, so we thought that morning closing keynote will be the best. And Neal will be presenting, but before that, I would like to thank you for coming here for sure, and I would like to show you something. You have the lanyards on your neck for sure, and you probably realize that it's a bit rough, right? And it's not because we wanted it to be like very strange for you to wear it, but there is something that I will show you right now. You can do it like this. Huh? Ta-da! Have you seen that? Who saw it before? Oh, really? No way. Every time that somebody came to us at the registration desk, he or she didn't know about that. So sorry about that. I thought that would be fun to show at the closing keynote, but it wasn't. Sorry. I hope that Neal will be better for you, so he will have something new for you this time. So thank you, Neal, for coming here. I heard that, like many speakers, they spoke last time in person almost 2 years ago, like February or March 2020, and this is the first time, like for the Jessica, for Neal, speaking in front of the real people, and probably last one this year. So I'm really glad that we were able to meet here and learn from Neal. Thank you, Neal.
Thank you. Check, check, thank you. So let's give a round of applause to the conference organizers for putting on this conference in unbelievably difficult, trying times. So excellent work. Thank you so much for fighting through all of the headaches to put this together. Welcome everyone to the final morning of the conference. This morning I'm going to talk about meta-modern software architecture. In my most recent book, The Fundamentals of Software Architecture, the entire second part of that book is dedicated to what we call these architecture styles and patterns, particularly these architectural styles, exemplified here. And in fact, here's a shameless plug. I'm going to be doing a talk this afternoon about this subject based on material from our book. But what I want to talk about this morning is, where do these things come from? Because we just kind of accept it as reality that, oh, these things are here, but how do they get here and where do they come from? Some people suspect that architects go and find an ivory tower somewhere and plot to think, what is the next thing that's going to be the big deal in the software development world? But unfortunately, it doesn't work like that. Our ecosystem, the software development ecosystem, is in constant shifting and changing, because people constantly build brand new cool things. And it's an equilibrium. We talked about this in the Evolutionary Architecture book, that the software development ecosystem is an equilibrium, meaning that all the pieces fit together and they kind of make sense, but it's extremely dynamic, because one day some new cool thing will come along. And then another seemingly unrelated cool thing will come along and make that even cooler. And that upsets the equilibrium. And then a bunch of clever architects and developers look at that and they go, you know, if I took one of those and two of those, I could build a brand new thing. And that's how we get new architectural styles. It's taking advantage of the capabilities that exist that have just arrived in the software development ecosystem. And after the fact, we name these things, because after enough people have done the same trick of applying the same magic tricks and observations to build a new thing, at some point you go, well, everybody's doing that, we should name it. And that's how these things come about. And When you're writing a book or doing a talk about something like this, you always look for metaphors or things that are related. And the other thing that struck me about the way these architecture styles kind of grow out of changes in the ecosystem and then eventually get named because you realize that they're all cohesive, or the similar phenomenon is around cultural movements. So let's talk for a moment about cultural movements. These are broad perspectives about the way entire societies view the world, sort of a lens in which they look at things in the world. And the first one I'll talk about, the first one that's really notable, is Victorianism, which was 1800 to about 1901. This was Victorians witnessed resistance to rationalism as defined by the Georgian period, increasingly turned toward Romanticism and even mysticism in many things. This is where a lot of this artwork came from. Realism was really important in the first part of this period, but then increasingly, as photography came along, that fundamentally changed art. Because now painters don't have to capture objective reality, they can interpret reality. Because now we have cameras that can capture reality, and so you get things like Impressionism. The British circus was huge at this time, so this was a big phenomenon in Britain. And you're probably familiar with this famous, iconic ad photo. This was a painting that was rejected by a British museum, but then became the logo for the RCA record company. Victorians also developed a lot of science and technology, and they actually believed that the same approaches you applied to science and technology could be applied to other things like philosophy and religion, and you could build these big sweeping frameworks that encompass everything and made everything make sense and kind of fit together. But after Victorianism came modernism, which is about 1890 to 1945. Modernism is a reaction to the development of the modern industrialized societies and the rapid growth of cities. That was a massive shift from rural economies into cities and industrialization and the machine age and the Industrial Revolution. Then it was followed almost immediately by reactions of the horror of World War I, which is this huge thing that influenced the entire world. Often the things that move these cultural movements are these worldwide phenomenon that changes everybody's perspective all at once. Some examples of that coming up. And modernism also rejected a lot of the early Enlightenment thinkings, and many modernists became anti-religious because it was part of the dogma that they were trying to cast off from the past. A lot of people felt that traditional forms of everything, art and architecture and literature and philosophy and all those things were becoming less and less relevant because something that was written in an agrarian rural society seemed less relevant if you were living in a huge city packed in with a lot of other people, and so people's realities seemed to shift and change and be different. A lot of the art in this period embraced things like absurdism. So this is especially in Europe, Waiting for Godot and Bertolt Brecht and plays like that. Theater of the absurd was part of this movement. And you also saw, well, it turns out, one of my favorite art movements, which is abstract expressionism. And I have to admit, part of the reason I wanted to do this particular keynote is to get to see some of these paintings on this beautiful giant screen behind me here, which is nice. This is, of course, Jackson Pollock, who the abstract expressionists were trying to get completely away from representation in art. That started with the Impressionists, and this was kind of the end of that road. But when they were painting like this, Jackson Pollock said that he was frustrated because people would come to him and say, "Oh, this is a nice painting. You know, I see a bunny and a doggy and a horsey." And he said, no bunny, no doggy, no horsey. It's just abstract. And so the kind of end of that way of thinking is actually my favorite abstract expressionist painter, which is Mark Rothko. Rothko, in his later period, only painted fuzzy rectangles. And this gets away from seeing a doggy or horsey or anything else in this painting except a fuzzy rectangle. And any photo does one of these disservice because they are actually hundreds of layers of paint to create that effect. And so when you see them live, they almost shimmer. They're just amazing paintings, but when you see a photograph of them, it's like, well, it's a fuzzy rectangle. I could write one of those, I could paint one of those. And you could, but not quite the same way. And of course, you didn't come up with the idea, which is the important thing about that. Radio was big in the modernism era, and that was the primary form of entertainment. In Victorian thinking, there was a single truth that could and should be agreed upon by everybody. Modernism rather encouraged the construction of complex concepts that somebody works toward, even if they understand that nothing is perfect and everything is a bit flawed. The thing that came after modernism was postmodernism. And if you think naming things in software is hard, try naming cultural movements. This is way harder, and all of these names are terrible, and I didn't come up with them. These are just the accepted names for all these things. I mean, you're kind of stuck if you name anything modern, right? Because what comes after modern? But modern kind of means now, so postmodernism started in 1945 and lasted until about 1990. Postmodernism is characterized by two major emotions that kind of eventually became the driver of postmodernism, which is skepticism and irony. Samuel Beckett was one of the writers in here, and people like Vladimir Nabokov, a famous writer here, William S. Burroughs, Kurt Vonnegut started in this period, E.L. Doctorow, Don DeLillo, Thomas Pynchon, in books like Gravity's Rainbow, Jack Kerouac, On the Road. The Beat Generation happened during this time period. This is when movies became really iconic and influential in society. But of course, the big thing that happened during this time period was the advent of television and TV shows and the way that affects culture generally. There's a great quote that I like to think of here because, television is a great example of one of those things that existed at the time I was born, and so I don't think anything special about television. And the same is true for your children and things like iPads, which I think is still a marvelous thing, but your kids it's just part of the noise of the universe. And there's a great quote by Douglas Adams that says that everything that exists when you're born is just a natural part of the universe and there's nothing important about it. Everything that's new between your ages of about 15 and 35 is the new cool stuff, and you probably have a job playing with that. And anything that happens past your age of 35 is that newfangled shit, and you can't figure out why anybody cares anything about that stuff. So that's TV for me, is it's always been there, and it's always had an influence on our world once it became such a cultural phenomenon until, of course, the internet ate it. But one of the key things that kind of grew out of the artistic world in postmodernism was irony. And Seinfeld is a great example of this, if you're familiar with the Seinfeld sitcom, because the mantra of Seinfeld by the writers was no hugging and no learning. No characters ever hugged in that show or showed any kind of affection for one another, and they never learned any lessons, which is part of the reason why you watched it, because they kept making the same stupid mistakes over and over again. Postmodernism distrusts big concepts. No big idea is true for everybody, and no big idea is complex enough to really reflect the reality of the world that we're in. So skepticism, everything is skeptical here, and everything is ironic, and there's reasons why irony became such a dominant force that I'll talk about in just a second. But let's go back to architecture styles for just a second, because exactly the way that we ended up with a name like postmodernism is in the 80s or 90s, people looked back and said, well, you can kind of group a lot of the thinking together, and we should come up with a name for it, and naming is hard, and so they came up with postmodernism. The same is true for every one of these architectural styles, except one of them. Because as we continue down this road of software architecture, we get more meta about things and start observing the process, as well as just consuming the technology and the interesting bits. And microservices is unique amongst these, because this was not named well after the fact. It was in fact named very early in its life by this famous article on Martin Fowler's website, written by Martin Fowler and James Lewis in March of 2013, I think 2014, March of 2014. This was very early in the days of microservices, but I think this did a great service to our community. Because normally the way we arrive at one of these architectural styles is a lot of churn. People start doing this new thing, and a whole bunch of people start doing it when it's really inappropriate, and then they crash and burn spectacularly, and you get the Gartner trough of despair and all this other bad stuff that happens with new technology adaptation. But what this article did was basically, in the very early days, say, well, this is what it is, but maybe more importantly, this is what it isn't. And that helped people a little bit, I think, understand what they were trying to achieve and get away from some of the really tricky things in that world. And of course, microservices is interesting because it adds a really interesting nuance to distributed computing. Because we've been doing distributed computing for a long time. In fact, Mark Richards and I, my co-author on the Fundamentals book, did a whole bunch of these event-based systems using a bunch of terrible technologies like Corba and DCOM and a bunch of other acronyms back in the late 90s and early 2000s. But when it came to decision-making in microservices, we realized that it was an order of magnitude more difficult again, and we got puzzled as to why that was. And we realized that, of course, one of the distinguishing factors of microservices is data fidelity. This idea of bounded context from domain-driven design, and the very wise observation that your database schema is part of your bounded context and should be part of your service boundary. But as soon as you accept the database into your service boundary, that means transactions are now part of your architectural decision-making in a distributed architecture. And in fact, one of the most difficult things that people have to arrive at now is how does communication work in distributed architectures. In fact, I did a talk yesterday about granularity and communication in distributed architectures because those are the two things that people are struggling with a lot. And what we recently realized, and is in fact going to be in a book that I'll show you in just a second, is that there are at least three fundamental forces you have to think about when you think about communicating between services in something like microservices. And one of them is what kind of communication? Is it synchronous or asynchronous communication? The next one of these is that transactionality I was talking about, consistency. Is it atomic or is it some flavor of eventual consistency? Now, we can have robust debates about the impossibility of doing ACID transactions in distributed architectures, but you can get either they all change or they don't, which is what we're referring to as atomic here, or an entire spectrum of flavors of eventual consistency. And then the third factor here has to do with the complexity of your workflow, and do you use orchestration versus choreography to manage that in your distributed architecture? Because it turns out that really complex workflows with a lot of boundary and error conditions end up really benefiting from orchestration. Because you can't make that complexity go away, all you can do is move it somewhere else and you end up spreading it around. What we've recently realized is that when architects try to make decisions in this space, they try to treat these as a la carte concerns, but they're not. This is a conjoined 3D space. And every time you change a decision from one place, it affects the gravity of what can happen in other places. And so one of the things that we've done in our Software Architecture, the Hard Parts book, is actually analyze all of these possibilities. So for example, something that is near the origin is synchronous, orchestrated, and atomic. And what makes us think that we're onto something here is if you go to the origin, that is in fact synchronous, orchestrated, and atomic, which is exactly what a monolith is without the distribution. And so as soon as you move off of the origin, now you're in this space. And so if you change things from atomic to eventual consistency, then you're over there. And so as you move this ball in that space, you change the decision matrix and the things that happen within the trade-offs within your architecture. So every movement changes your trade-off. So if you want to change to asynchronous atomic behavior, you would move it up there. Some of these are patterns. and some of these are anti-patterns. We named all of these as different kinds of sagas because these are all sagas in the transaction world, so these are all different kinds of sagas, and this one is in fact what we call a horror story. But this is one of those anti-patterns that you accidentally stumbled into because this is atomic, asynchronous, and choreographed. But what happens is, okay, you start doing an atomic transaction and then it's really slow. And then somebody says, well, the way you speed it up is do asynchronously. So, okay, we'll try that. Oh, and the way to speed that up is to go eventual consistency, not eventual consistency, choreography and asynchronously, but now you're still trying to maintain transactionality, and it is in fact a horror story. And so decisions in this space are very, very complex, which is one of the tricky things about modern architecture. So what happens after postmodernism? Well, it turns out the name for this is either metamodernism or, wait for it, postmodernism. There are actually some people who refer to this movement as postmodernism, and I can only imagine where that's eventually going to end up, and that's not a good place to be. So what is metamodernism? It's the current period we're living in right now, in fact, is metamodernism. And the first person to really explain this in a really nice way is this author, David Foster Wallace, who wrote nonfiction and fiction, one of the greatest works of fiction in the 20th century. But he wrote this book, a collection of essays called A Supposedly Fun Thing I'll Never Do Again, which is about him going on a cruise ship. Which is the supposedly fun thing that he will never do again. But one of the essays in this book was an essay called E Unibus Plurum, Television and U.S. Fiction. And he suggests why irony became such a dominant force, particularly in TV. Because he made this observation in this essay that writers love observing people, because that's how they get raw material to write about. But they're also frequently introverted and hate being observed. And so how do you observe people without also being observed? Because if you go on public transit or something and sit and stare at someone intently, they'll eventually look at you and go, hey, why are you staring at me like an insane person? But it turns out the perfect medium for watching without being seen is television. Because it also features experts at being seen but not seeming to be seen, who are actors, because they seem natural being seen. And so a lot of writers, rather than going out and living a real life, just consume TV. But there's a danger in that, because if a writer goes out and consumes real life and writes about it, then that's a genuine experience. But then the next writer experiences that through the flatness of TV, and whatever they write about is going to be a one-off copy of that that's not very good. And then what they produce is going to be the next thing, and so before long, the only emotion that's really left is irony, self-referential irony, because there's nothing else left, because you've flattened everything down to that single emotion. He also wrote this magnificent book called Infinite Jest, which is very well worth reading. Quite the adventure, that one. But what I haven't talked about until now is what causes the shifts between these eras. And the shift that caused postmodernism to become metamodernism was the internet. Because the internet changed everything for us. And there's some great examples of this. So let's say that it's 20 years ago, and I need to travel to Krakow for a conference, and I need to know what the weather is going to be in Krakow pre-internet in 2 weeks. How am I going to do that? Well, I could go to a TV channel like the Weather Channel and hope, but they only do U.S. weather, so I can't really find an international one. I could go maybe to a library and get a newspaper or something, or I could call somebody here and ask them. It would be really, really cumbersome to figure out what the weather is going to be in 2 weeks somewhere where you don't live. But when the internet's there, trivial. I can open my phone and tell you in 10 seconds where the weather is anywhere on planet Earth. Here's another example. Let's say that I'm a journalist and I want to write an investigative piece about the origins of wine. And it's 1985. How would I go about researching that? Well, I'd go to the library and I'd read books about wine. I'd find publications and newspapers and maybe find a wine appreciation society somewhere and talk to them. But by the time I'm done, I've probably covered 85 or 90% of the available information on earth about wine. But try doing that in 2021. Because everything is constantly, there's new wine stuff every day, every hour, every minute on the internet. Everything is constantly growing and shifting, and you can never be comprehensive about anything anymore with the internet. There's some interesting artistic pieces in metamodernism. This is a piece by Sturgill Simpson, who's a country music performer. And the name of this album is Metamodern Sounds in Country Music. And he takes all these different styles and mashes them together on this album. Because one of the key ideas in metamodernism is holism. Realizing that you can't take a narrow part as the whole thing. Everything is huge and complex and messy and multifaceted. And you can't really reduce things down to simple little arguments about things because everything is big and complex. Some of the entertainment that came out from metamodernism are things like The Office or even more Parks and Recreation, which had this weird meta-narrative. It was almost shot like a documentary, but it's also a sitcom. But there's a lot of genuine sentiment in this. That's another aspect of metamodernism that David Foster Wallace called out. He said, I'm tired of irony because it just goes nowhere. I want to embrace real sentimentalism again. There's a great article here on Huffington Post by Seth Abramson, who is an attorney and journalism professor, but has also written extensively about metamodernism, including several anthologies about metamodernism. Some of the more modern entertainment on streaming is a great example of this, including Breaking Bad, the series, which is, of course, an interesting plot in and of itself, the way things go very fast through here. But the other thing that's very metamodern about this, well, a couple of things. One, it's much deeper than you may realize, which I'll talk about in a second. But there are no good characters in Breaking Bad, no good people. But no real bad people either. Everybody's both good and bad and flawed in all sorts of interesting ways. If you're not familiar with this, I'm going to give you a fun thing to watch for the next time you look at Breaking Bad. There's a clue. One of the characters is named Walter White, and the other is named Jesse Pinkman. That suggests that colors are important in the Breaking Bad universe, and it turns out they're extraordinarily important. If you look at a standard color wheel, in the Breaking Bad universe, anything that is yellow is safe and wholesome and unbroken good, and anything that is purple is unsafe, drug-related, and Breaking Bad. In fact, there's one scene in the series where somebody who's about to do something evil takes off a yellow shirt and puts on a purple shirt. The symbology is in every scene of Breaking Bad if you look for it. Walter starts the series in khaki pants, yellow pants, and ends the show in all purple shirts, occasionally one with some yellow stripes because he's trying to act like a good guy. And so it's worth watching this again if you didn't see that the first one or two times through, because Breaking Bad is this very complex puzzle of plot and character development and color symbology and a very complex interwoven thing. Another great example of that is Game of Thrones. There are no good people in Game of Thrones. Everyone is awful in some way or another, but that's much more like the real world that we live in. In terms of sentimentality, I haven't actually watched this, but people rave about this show Ted Lasso because it is absolutely unapologetically sentimental. And people find that refreshing because we haven't had that in a long time, another characteristic of metamodernism. This holism is a really important characteristic of metamodernism. And in fact, this is something that I see reflected in a modern perspectives on software architecture a lot. That you can't just look at narrow things anymore. You have to look at things in context and evaluate trade-offs. So let me give you some examples of what I mean by that. When we were writing the Fundamentals of Software Architecture book, one of the things that we wanted to do is keep an eye out for things that seemed universally true across everything that we talked about. And we ended up finding 2 of those things that we codified as these 2 laws of software architecture. And the first law of software architecture says that everything in software architecture is a trade-off, which is a very meta-modern kind of view of software architecture. And there's a corollary to the first law that if you think you found something that isn't a trade-off, it just means you haven't discovered what that trade-off is yet. This, in fact, gives you a new way of thinking about something that has plagued us for a long time, which is how do you define software architecture? Well, we have a new definition that I'm going to try out on you to see how you like it. A software architecture decision is one where all the options have significant trade-offs associated with them. This encompasses the stuff to change later definitions and the other vague definitions we've had in the past, because if it doesn't have significant trade-offs, then it's design, it's not really architecture. So this is a way of thinking about architecture. So let me give you a few examples of this. And this is something that, for whatever reason, I bumped into several times quite recently on client work, which is a misunderstanding of how reuse should work in software architecture in particular. Back in the days of the big, giant, orchestration-driven, service-oriented architecture, part of the goal of that architecture was to try to reuse as much as you possibly can. And so architects in that era were instructed to look for this pattern. So let's say that you're a big insurance company with all these different divisions, disability and auto insurance, et cetera. And all of these different divisions of insurance have some aspect of customer in them. Back in that era, as an architect, you were instructed to look at that and go, hey, wait a minute. All of these have some kind of customer stuff in them. Therefore, what I should do is consolidate all that customer stuff into a single customer service. Now my work here as an architect is done. Turns out, though, there are 2 problems with doing this in architecture. The first is one that Eric Evans talked about in domain-driven design. Is if that customer service has to know everything your organization knows about customers, it's going to be really complicated. And in fact, it's going to have a whole bunch of stuff in it that none of these individual divisions care about as their part, but they have to deal with the overhead of these required things that they don't care about, which is, of course, not great, but survivable. The part that's not survivable is if you build an entire architecture around this idea of maximizing reuse as much as possible, you have created a brittle architecture. Because now every time you change the customer service, that change ripples out to all the places that touch this service. And if you've built the entire system around this idea of maximizing reuse, you make a single change and the whole thing comes crashing down like a house of cards. And so what people don't understand is that reuse is good, but there's a trade-off associated with it because this is an architectural decision. And of course, the trade-off there is really high coupling. And this goes toward the microservices world, where the idea is try to prevent this kind of coupling as much as possible. So the more common practice in places like microservices is to have your own internal representation, a la domain-driven design bounded context, and then embed that information in messages, but don't create really strict contracts between things because that creates breakages in your ecosystem. And that's what we're trying to avoid, this kind of brittleness. Because it turns out that if you couple too much around domain things change a lot. Because your market evolves, your requirements evolve, and you don't want to create really tight coupling points around those things. But this is a great example of, in the orchestration-driven SOA world, reuse, regardless of what kind, was considered a good thing. But in the microservices world, we generally prefer duplication over coupling. But what about times when that's not the appropriate thing to do? Because what are we coupling to or preventing coupling to? And so there's a lot of interesting work in the microservices world right now around this idea of sidecars and service meshes as a way to achieve orthogonal coupling in microservices. Because it doesn't take long building microservices to realize, wait a minute, there's a whole bunch of shared behavior that I really want to be consistent across all of my services. Things like service discovery, circuit breakers, monitoring, logging, all those sorts of things. I would really benefit if all those things were consistent across all my services. And I could leave that up to the individual service teams, but how do I make sure that they're implementing it in a timely manner? And how do I manage things like upgrades? If I need to upgrade to the next version of the monitoring tool, how do I coordinate that over the entire world? And so the practice has arisen around this idea of a sidecar. Why don't we take those common behaviors that everybody needs and put them in a sidecar component? Shared service team can own that sidecar component and put monitoring, logging, whatever they want in that, and each domain team just snaps that sidecar into their service, and we're good to go. That allows you to couple things together that you want and benefit from being coupled together without forcing you to couple together your domain concepts. And of course, if you know that every single one of your services has this consistent interface, then you can create a dashboard, and that's this idea of a service mesh or orthogonal coupling across an architecture. Because now this allows you to couple the things together that you want coupled together, but keep your domain concepts extremely decoupled from one another. And notice that any one of these things can be cheated on, so it is officially considered cheating if you put the customer component in the service mesh, because now you're using the incorrect mechanism to spread something around. So it's not illegal, but it is considered cheating. People misunderstand reuse, and so what is a more meta-modern approach to reuse? Well, it really takes some nuance here, because the way you get to reuse is abstraction. You realize that, hey, these four things all need to do the same thing. Let's abstract that out to some sort of reusable thing. And a lot of places stop there. But the real secret to making it effective at the architecture level is slow rate of change. The slower the rate of change, the nicer it plays in your integration architecture, which is one of the reasons why so many places are obsessed with this idea of internal platforms now and APIs around internal functionality. Because what that lets you do is take a group of related services and put them behind an API that has a very slow changing interface, and you can now make changes inside at a rapid pace without breaking all of your integration architecture stuff. So slow rate of change is really the way that you operationalize reuse. Anything that has a high rate of change, you need to figure out a different way. Either don't reuse it or figure out a different mechanism for that. Part of the realization of modern architectures is that there are no silver bullets left. I'm sorry to tell you that if you have a gun that's specially suited for silver bullets, I'm sorry that they are pretty much gone. I recently discovered, because I was copy editing the Software Architecture to Hard Parts book, the actual essay is titled No Silver Bullet. There's not an S on it. And I've always thought there was an S, but it turns out the original essay says No Silver Bullet. Because in the architecture world, nothing is generic. Mark Richards, my co-author, has a great quote that says, software architecture is the stuff you can't Google. Because when you're a developer, you hone your Googling skills. Because you have something that's going wrong, you figure out how to Google just the right part of the error message to figure out what's going on, and so you hone those skills. But when you get to architecture, think about the architecture where you are. It's not this perfect, beautiful thing. It's a combination of stuff we like, the stuff we don't like, the stuff we're stuck with, the integration points that we have to use, the old software that we have to integrate with. What are the chances that anybody else on earth has that same unique snowflake combination of things and has the same problem you currently have and has taken the time to write a nice Medium post about how to solve that problem? The chances are getting smaller and smaller and smaller. And so your job as an architect is not improve your Google skills. It's to learn how to do trade-off analysis. That's the key job of an architect. And so one of the things that I tell people as new architects is get rid of some words in your vocabulary, like always or never, because it depends. It's just a different set of trade-offs. When somebody says, oh, you should never use that, one of the things I like to do is point out, well, in this situation, you would need to use that, because it's always a different set of trade-offs. There are almost never any absolutes in the architecture world, which is one of the reasons why software architects always look so grumpy, because you can't pick sides and have fights, because everything is this messy gray area. And so one of the things I tell aspiring architects is don't evangelize stuff. You're just asking for trouble if you're evangelizing stuff. It's all about trade-offs. Your job is not to find a silver bullet and bring it to somebody as the ultimate solution. Your job is to analyze the trade-offs, the good and the bad, and give those analyses to decision makers so they can make the best informed decision. Understanding how to analyze trade-offs in your ecosystem is one of the most important skills that you can master. And every ecosystem is a little bit different, but there are, of course, some skills that you can work on to look at what the real trade-offs are within an ecosystem. A common anti-pattern that pops up here is people who try to force you to evangelize the other half of an argument. I recently had a tech lead come to me, and he wanted to argue with me about mono-repos versus feature toggles. And I'm not evangelizing either one of them because they both have trade-offs, but he wanted to pick a fight, so he wanted me to take the feature toggle side because he really wanted to fight about mono-repos. And I refused to engage. I said, look, they both have different sets of trade-offs. And of course, what was going on was he knew what the negative trade-offs were, and he was downplaying those and amplifying the good side for his argument. And so I told him, okay, you think we can do this successfully without encountering any of these anti-patterns? Let's do an experiment and try. It's the only way to know for sure, and it turns out we did an experiment, and of course developers forgot about those guidelines after about a week, and we bumped into almost every one of those anti-patterns. So don't fight about things, demonstrate things. Demonstration defeats discussion. Don't have discussions about things, actually demonstrate what's going on. This trade-off analysis is really about embracing holism in architecture, that all these pieces are there and they all have different sets of trade-offs. And in fact, that was the focus of this book that's coming out in about a month now, because we're doing copy editing on it now. And you'll notice the subtitle of this book is Modern Trade-Off Analysis for Distributed Architectures. So we do a fair amount of work in this book about showing you a bunch of trade-off analyses, but then we show you at the end how to apply this to your own unique, beautiful, broken ecosystem that you're working in. So let's talk a little bit more about what causes these cultural movements to shift. And the perception of scientists before 1945 was mostly these kind of good-natured, eccentric, these guys are kind of kooky kind of perspective on physicists. And in fact, Jessica, in her keynote 2 days ago, talked about John von Neumann, who's a very interesting character. I'm going to talk about a different Los Alamos physicist, Richard Feynman. Fascinating character if you've never read about Richard Feynman. There are a lot of books about him. Really fascinating character. You may have heard, this is not a Richard Feynman concept, this is somebody else, of 6 degrees of separation, which is a very postmodern concept, by the way. This was originally called out in a play by John Grier that says that everybody on earth is 6 degrees of separation from other people. The idea is that if I know somebody, they know somebody, etc. Well, it turns out that I am 3 degrees of separation from Richard Feynman, the physicist, because I have a colleague in Australia named Scott Shaw that used to work with Feynman's son, who, of course, has a direct relationship to Richard Feynman. So I'm 3 degrees of separation away from Richard Feynman, which means I'm 4 degrees of separation from John von Neumann. So that's how that works. So you can get to all the nuclear physicists through that. But he was a really fascinating character because he was so eccentric, and a little bit like John von Neumann, he was also a very curious character. He did work in physics, but he also did work in a lot of other fields. In fact, he created one of the very first parallel computers, and I want to show you a picture of it. It was this. Back during World War II, they didn't have computers, and they needed artillery trajectory tables. And so they had computers. If you look in the dictionary before 1945, a computer is someone who computes things. So they had these huge rooms of almost all women, because the men were all fighting the war, using adding machines and slide rules to do artillery trajectories. And Richard Feynman figured out how to make it a parallel computer, because it turns out that some of the women were better at logarithms and some were better at adding, so rather than make every woman do each thing, he assigned them each a job and created an assembly line, created threading, figured out how, if somebody made a mistake, how to not stall the entire thread and start it back where the mistake was, a lot of really clever stuff like that. He also created, one of the creators of quantum mechanics, and this is how he won his Nobel Prize, was work in the quantum mechanics world. But somebody said of Richard Feynman, and I think this is very true, that it's really good that he won his Nobel Prize relatively young in life. Because if you act the way Richard Feynman does and you're a Nobel Prize winner, you're just eccentric. If you act the way he does and you're not a Nobel Prize winner, you're an insane person. And let me show you this. Here's some actual video of Richard Feynman playing with bongos. He was really into bongos as well, and drumming. Apparently also really, really into orange juice, which is what this song is about. So what moved us from the modern era to the postmodern era? Remember, there's a hard date, 1945 is when that era changed, and it's exactly what Jessica was talking about yesterday. 1945, as soon as the atomic bombs went off, it changed the entire world forever. Because now we realize that there's a time we could destroy the entire place, either by accident or on purpose if we wanted to. Feynman was the only person to actually witness the first blast. Remember when Monday Jessica said they didn't really understand a lot of the implications of the radiation and other stuff. They used to hold the ball that was the middle of the bomb, and they would hold it and marvel at how warm it was at room temperature. Of course, they're giving themselves radiation poisoning. They didn't realize that. It's like, oh, it's cool, it's warm. But he realized, he knew the physics behind this. And everybody else was wearing like welder's goggles and all that, but they were miles away in a bunker. And so he took the welder's goggles off and actually stuck his head up and actually saw the thing go off in the distance, because he was pretty convinced it wouldn't blind him. And he didn't. So he actually saw it eyewitness without the welder's goggles on. But like many of the Los Alamos scientists, he was a young man when he was working on that, very young, in fact. And he was blindsided by the implications of the thing that he had helped create. And later in his life, he really struggled with this. And he had a famous quote that said, talking about the atomic bomb, with any project like that, you continue to work on it, trying to get success, having decided to do it. But what I did, immorally, I would say, was to not remember the reason I said I was doing it, so that when the reason changed, Not the slightest thought came to my mind that meant that now I have to reconsider why I'm continuing to do this. Robert Oppenheimer, who's running that project, actually quoted Hindu scripture when he saw the thing went off and spent the rest of his life trying to prevent the spread of nuclear weapons, even though he had been instrumental in actually creating this stuff. A lot of these scientists suffered greatly the remaining part of their lives because of what they were involved in. And their point was, when the war was over in Europe, they should have stopped working on the bomb, but they were caught up in the puzzle-solving part of it until they were finished. And in fact, in a weird kind of, Jessica did not coordinate at all on our keynotes, but in a weird bit of synergy, you may have noticed the name of the conference room that we are in. This is a very famous Polish composer who only died last year, and one of his most famous works is Threnody to the Victims of Hiroshima. So this is his meeting hall. Once 1945 came along, the idea of the evil genius entered into our popular culture, and James Bond villains with shaved cats and all that kind of stuff. And scientists became, for the first time, people that you couldn't really trust, that needed to be feared because they can do things that cause really bad things to happen to the rest of the world. I mentioned before the transition from postmodernism to metamodernism was driven by the internet, and that's what's driving a lot of holism. And if you look in the early parts of the computer world, software developers were these very, very harmless dweeb, geek, nerd, all these terms we have for them, for these kind of harmless, people that have poor social skills. But increasingly, we're being viewed differently because of the things that are happening because of software. A few years ago, Volkswagen got busted for cheating on emissions tests, and it turns out they had wired the cars to detect when it was in test mode so that it would give different readings than it was actually on the road. Somebody obviously made that decision, but somebody also coded that decision. Now, you can build levels of isolation around things in companies so that people don't actually know exactly what they're working on in some cases, but some of those developers knew what was going on there, that they were cheating and doing something wrong. But maybe the poster child of doing bad things in software is Facebook. Facebook has this long litany of bad things, and it just keeps being bad. Data breaches, illegally tracking users when they're not supposed to, Cambridge Analytica and all the information they expose through that, using two-factor authentication emails for marketing purposes. They keep getting busted over and over for doing really evil stuff. One of the founders of Facebook, and of course their algorithm is the main driver of all this. And Sean Parker, who briefly served as Facebook's president before he resigned, he said, Facebook is exactly the kind of thing a hacker like myself would come up with because you're exploiting a vulnerability in human psychology. The inventors and creators understood this consciously, and we did it anyway. So why won't Facebook stop being so bad about these kind of things? Well, part of this has to do with the perspective of how companies function. And this very much comes from a modernist perspective of the world. I suspect that the people at Facebook at some point had a reckoning and said, we could stop doing all these bad things and be a $250 million company, or we could keep doing the bad things and be a multi-billion-dollar company. And I think we know where they ended up landing on that. But this goes back to these cultural phenomenons, because modernism brought us balance sheet accounting. This is a relatively new phenomenon in the early 20th century, and this moved from Europe to America, and as people moved to cities, and the balance sheet became the way you assess the valuation of a company, and then we became obsessed with that. In fact, a few years ago, a psychologist did a psychological evaluation on a company as if it were a person, and it turns out that corporations are psychopaths, because they only care about one thing, which is the bottom line. The postmodern world gave us quants and the ability to hack the system and figure out ways around it, make massive sums of money. But what metamodernism bringing us is this idea of the humane corporation, a corporation that doesn't only care about profits, but also cares about leaving the world a better place than it found it. ThoughtWorks, the company I work for, has long been involved in this. We used to call these three pillars, they're now lenses, but these affect every decision we make. We don't just look at the profit, we also look at, is this making the technology world better? Is this not hurting people? We don't tend to work for people who exploit other people or do objectively bad things, because this is a holistic view of the world and very much like a meta-modern approach. And the thing that, so Jessica on her keynote said that we need to do more systems thinking generally, and I'm going to hone in one thing specifically you need to think more about. And that's the ethics of what you write in software. You cannot continue to dodge it forever, just like the physicists couldn't dodge it forever. Like it or not, we're all connected to one another exuberantly, and you can't avoid that. And this is one of the former Facebook executives who, in an interview, said, "Do I feel guilty? Absolutely, I feel guilt. Nobody ever thought you could have such a massive manipulation of a system. You can see the reaction who run these social media programs. They never thought this was possible." Welcome to the modern version of someone who's going to spend the rest of his life regretting what he did as a technologist. Fortunately, we are the ones that can change this. Google employees are now pushing back on work that Google is trying to get them to do that is not ethical. And ultimately, though, who is going to teach the programming world to be ethical? And of course, the answer is you. The people on the ground are the ones who have to think about this. Ethics is a part of your profession, whether you realize it or not, and it always affects people, and you have to be careful about that. There's an essay here called Against Software Development that brings up the pertinent points here. To those who have a choice, refuse to work on systems that profit from digital addictions. Refuse to work on systems that centralize control of media, that prop up an unjust status quo, that require unsustainable trade-offs, that weaponize the fabric of society. Above all, refuse to work on systems that understand and manipulate people, but offer no affordance for their subjects to understand and manipulate them. Work on something that matters, if only to you. Work on something that helps people, even in small ways. Work on making things understandable for other people. Once upon a time, software let a lucky few of us escape to virtual worlds, choose our own communities, and explore alternative realities. These days, for better or for worse, software defines everyone's reality. Let's build one together that's worth living in. Thank you very much. Have a great rest of the conference. Thank you.